this entire talk is being presented in Compiler Explorer because I have no idea why. I've decided since I started, since we've gone virtual, that I just don't like creating slides anymore. So all of my talks have been something somewhat experimental. So here we are. This is somewhat experimental again. Hopefully stays full screen properly. I guess I should introduce myself. My name is Jason Turner. We didn't introduce ourselves at all, Scott, at the beginning of this, I don't think. This is, I'm one of the leaders of this meetup along with Scott here, but this is definitely a group thing. Everyone just kind of pitches in and makes sure that it happens, particularly when we're meeting in person. So the talk today, April 1st, it is not an April Fool's prank, just for the record, but my talk is specifying and qualifying your member functions. This is a talk that I've wanted to give for a couple of years now, and I just haven't gotten a conference to present to accept it or anything. But here we are. So because I have the power to decide what talks get accepted to my own meetup, it got accepted. These things are all valid here. And this is going to be, like I said, everything here is very informal. Please interrupt me and stop me and ask questions. But these things are all valid. And this looks like nonsense garbage, right? We've got maybe unused, deprecated, no discard, no return, friend, inline, Constexpr, Constituel, virtual, const, volatile, like random, and signs here. This looks like I'm saying volatile and no except. What is that about? Override final. And these things can be in all kinds of different orders. We've got equals default, equals delete, equals 0. You can put an extraordinary amount of markup around your member functions. So the idea for today is that we're just going to go through these things and talk about what they all mean. Why are they here? Maybe we'll talk about best practices kind of questions a little bit, but mostly we're just going to talk about the fact that these things all exist. And if you find by the end of the talk that I have forgotten something, let me know. Ooh, look at this. Clang Tidy doesn't know how to format conditionally explicit yet. It wanted to break that on the parenthesis. Bad Clang Tidy. That's a C++ 20 feature. We'll get to that. All right. So what the heck does all of this mean? I'm going to start with the things that are in brackets. Now, a quick rant, these square things, they're brackets, okay? They're not like square braces. They're not whatever else you want to call them. They're brackets. So these things, they're called attributes. Attributes were added in C++ 11. And I've got 4 here that we can no requires clauses, curses. Ben just called that out. Trailing return type. Ooh, okay. Look at this. You're supposed to interrupt me, but I don't think no unique address applies to member functions, right? That would only apply to values or parameters. Okay. Static. Technically, it's not a member function if it's static.
Data members, not parameters, but yeah.
Right, data members. Okay, sorry. Right, I haven't used no unique address yet.
Bases, yeah, probably.
I can't even get past the first half screen. Trailing return types, I could have added trailing return types, but in my opinion, that wasn't a way to decorate your function to give more information about the function. So that's why I didn't put trailing return types. Requires clauses, you're right, Ben. I missed requires clauses entirely. That is not in here at all. We're going to ignore that for the moment. All right, align as, again, that's also for data members. Oh no, that's for the class, but that's not for member functions, right? You can put that on the class, but not for member functions. So I'm just trying to talk about member functions. So I think the only thing I agree with that I completely missed is requires clauses. All right, I'm looking for nods. All right, fine. So yeah. All right, requires clauses missed. All right, so we've got these things. So maybe unused. This just simply says don't warn if the function's unused. It's rare that your compiler is going to warn if a member function is unused, but some compilers, some tools, in some cases actually will warn and say, you've got this I'm sorry, I am not used to doing this right now, so I'm reading the chat window on the side here. With some tools, with some settings, it will actually warn if you have member functions that are unused. So this says don't warn if it's unused. All right, no discard means warn if the return value is ignored. So we'll get into what each of these things mean. Deprecated is like warn if the function is used at all, because you're saying this function has been deprecated. It should never be used. And no return means the function can't return. The compiler, depending on the situation here, is actually going to do different calling conventions internally when the generated assembly. So I do have the generated assembly out here. So I've got just my little example of no discard. If I call the function getVal, which is marked no discard, now this applies to a free function just the same as it would to a member function, then I get this warning, ignoring the return value of a function that was marked no discard, declared no discard. There we go. And just for comparison, this get another val, if I comment that out, there's no warning. I'm allowed to ignore the return tar. Deprecated with a reason. Was deprecated with a reason added in C++? When was that added? Or was deprecated always had a reason? I can't remember.
You're thinking of no discard should have a reason, was a paper.
Yeah,
no discard with a reason was added in C++ 20. That one I know.
Deprecated reason came in early, I think.
Okay. All right. So yeah, so you can, in fact, all right, let's go ahead and do that here. Something like that. So we can put a deprecated with a reason in that example up there. And let's go ahead and play with it, I guess. Okay, right. So I guess we just did no discard, no return. I've got these two functions, some func and another func. One of them is marked no return. So this is just interesting. If we go into the example no return and I call another func, then I can see here this is a jump function. So it's a jump. It's going to save the return place, and then the function can ret and come back from it. Yeah, we're not going to talk about lambdas at all. Member functions, Ben. Member functions.
Those are objects have member functions.
Member functions of user-defined classes. Okay, so doing a jump call here, and if I comment out the sum func, then I know it's not going to return, so it actually does a call instead of a jump. Now, the interesting question is, what happens if I uncomment another func? As I just realized, I did not try this before. Is it going to actually generate a call to another func when I just told the compiler that there's no way for some func to ever return? I don't know. Does anyone know? Let's find out. Uncomment them both. And nope, the compiler completely removed that call to another func because you can't return from some func. And then deprecated and not deprecated. So let's get into that, I guess. Don't you want to actually like put this comment in your like coworker's code or something at some point? All right, so we'll call this deprecated function, and we should get an explicit warning here saying, warning, deprecated, this function is deprecated. Ugh, why are you using this function? So awesome. This is, by the way, GCC trunk that I'm using at the moment. Okay, any questions on the no return, no discard, I don't have an example of maybe unused here because it's hard to get the compiler to generate a warning, but you can put maybe unused on functions as well. Ooh, carries dependency. Ah, I haven't ever used carries dependency yet. There is not a C++ weekly episode on that. So carries dependency is for member functions also? I'm not going to click on that lest I mess up my streaming here. Okay. Okay, which of these are illogical?
I have an observation.
Yes.
Just something useful. I've seen no return deprecated also, but I prefer no return because deprecated means something more often. But I've seen these used as function templates. So if you make a function template that it's for identifying your types, basically you can call the function and the compiler will warn that you called it, and it will print the types that you passed it. It's useful for type-based programming.
Oh, for basically using that to debug your templates.
Yes. Yeah.
Basically. Okay. That's a good idea. Interesting idea.
Yeah, if you write a no return function that does return something, you'll get the warning or error, I guess.
Yeah, and I totally agree, by the way, the comment here on the chat, no warning for code after the function call that GCC removed, and it didn't warn on that. Totally agree. It should have warned on that. And I do have WL and W extra at least enabled here. So that's a weird one. All right, so which ones of these are illogical to combine, but we still can without getting any warnings?
No discard and no return seem weird to put together.
Yeah, no discard and no return. How in the world are you supposed to deal with that? But we totally can. We can put no discard and no return here. We can even see that all of my examples have no discard and no return in them. Ooh, look at that fancy highlighting all of them at once. And the compiler is not giving any warning on that at all. That's completely illogical. And also note, I actually didn't realize this until I was reading the standard, that these attributes can go after. And if you actually look at the standard, it actually says the attribute sequence comes last, but I've only ever used it on the front. So the grammar specifies it as coming last, unless I completely misread it. But clearly we can put it in either place without getting any kind of warning or error here. And just to make my point, if I try to do something like that, I'm going to get a compiler. Well, I got a warning there that it was ignored. Like, depending on where you put it, it's going to break your grammar. You might get an error. You might get a warning. But it seems to be fine on either side. What is no discard void even supposed to do? That's a very good point. No discard and void. Oh, and Clang doesn't like the trailing no discard. Okay, so there we learned something. Yeah, maybe I misread the grammar, but I'm reading through it and I'm like, wait a minute, where's the attribute sequence? Oh, it's on the end. How did it get on the end? That's weird. It does make more sense for no discard to be at the front. Maybe the no discard attribute is actually part of the return type part of the grammar and not part of the function declaration part of the grammar. Not sure.
I think everything should be after the function, like function name, arguments, trailing return type, and then all the junk. But you know.
Well, apparently Kling's not going to let you do that. I like no discard at the front. Just because then when you're reading the code, you're like, oh, well, this is an important return value from this function. But I could see an argument either way.
Does it work before the trailing return type?
All right, so let's go ahead and try this then. All right, so no discard attribute can only be applied to functions or class or enumeration type. So it's not even applying it to the function. I don't know what it thinks it's applying it to. No, looks like no discard has to be at the front. Here. Okay. Wow. Attributes. We'll move on. All right. Combining no return and no discard really doesn't make any sense. But there's probably more homework to do here, and I'm sure one of you will tell me what the difference is between. Yeah, like why is this one compiling? I put no discard at the end of this one and it compiled. Weird. Okay. Someone will have to figure that out. Okay, so friends, now to be fair, I said I left out static because I was only talking about member functions, and arguably statics aren't member functions. I may have just been covering for myself because I didn't think to put static in here, but that's fine. But friend is interesting because it's also not a member function. If I declare this function friend here, like I just have for my class F, it's actually for declaring a free function that is a friend. This is not a member function. This is a for declaration of a free function. So then I can go ahead and I can declare my example friend here that takes an object of type F and it operates on its private data. So a friends in C++ can operate, see each other's private members. Wait, I have to get rid of this warning because otherwise it's going to be throwing me off for the rest of this talk because I'm not expecting to see warnings over there. So if I take away this friend declaration, and then this is a compile time error because a friend is we're a free function trying to access the private member of this class F. So that's what friend is doing. So it's not actually a decorator on a member function, but I felt like it wanted to be there. Let's see. How do you declare or write a directive for a pointer to one of these functions with all of the qualifiers? Do you need to replicate everything? Asked Ben. You don't need to replicate anything that we have covered yet because we've only covered attributes and friendship. But once we get a little bit further along, yeah, you have to talk about all the things. As far as I know, because attributes are not part of the type signature. If we think about it from a name mangling perspective, attributes are not part of the function signature. The return type is part of the function signature. And then the qualifiers, the const volatile and our reference qualifiers that we'll talk about later, and no except are part of the function type. Yes, a free function is a free function, a non-member function. A free function is not a member function. A free function is a function that lives outside of a class or struct. And all of these examples right now are classes. They will switch to struct in a moment because I got bored of writing public and private here, and struct is just easier because everything's default public. That's an interesting point, Jacob. No return should matter in function pointers somehow, because the compiler would use different calling conventions with it. All right, been tested. Okay, so that's friend. Inline. Inline can change the linkage of a free function. For a class member, most people just use inline as a hint to the compiler to say, pretty please inline this member function for me when you go to call it. And they can be problematic because some people think that they need to put inline like everywhere. You generally don't. But that's all that I'm saying here is basically, pretty please compiler, would you mind inlining this for me? There's no guarantee that it's going to inline that function call. There's no requirement that it's going to. If you do this with Clang, Clang's optimizer does its own calculation for whether or not it thinks a function should be inlined. And if you add inline keyword here, it just does like +1 on that calculation, just makes it slightly more likely that it's going to decide to inline it. But there's a whole lot of other things that come into play. And I guess I should ask at this moment, does anyone want me to explain what inlining a function actually means?
There like on the Windows ABI, I think the inline can be significant when you're exporting DLL symbols. I'm just trying to look up some history on that. But anyways,
I've only had it matter with, I mean, DLL export is important. And then you might have to do inline for an explicit template instantiation if you want that shared across DLL boundaries, I think. But for member functions, I don't recall that ever coming up on Windows. I could be wrong.
Yeah, I'm just looking. So
yeah, so Mo asks, while you're looking that up, Mark, Mo asks, isn't inline just textual substitution of the function? And yes, that is basically the case here. Oops. It's if I have an object of type I, and then if this function is going to be inlined, if func is going to be inlined here onto line 121, I mean, it's an empty function, so yes, it will be inlined. It's basically just saying that's basically what inlining is doing. It just takes the body of that function, pastes it in there. It can actually result in very good performance improvements, because you don't have to like push the values onto the register into registers or push them onto the stack or whatever to be able to then call the function and then return back from the function with the jump and the call and the return and all that stuff. If it can just be pasted in there, then that is usually better. But it's going to make the compiled code larger also. And then you have all kinds of other performance questions about like whether or not you are going to put too much cache pressure in the CPU and not be able to push other important things out of the cache because you inlined this function or whatever. So that's why, generally speaking, putting inline on a member function is considered a code smell, or even on a free function, unless you need to on the free function for linking purposes, because the compiler knows better than you do whether or not it's a good idea to inline this code here. If you see inline on a function, then I want like a comment that's like, you know, something like this, right? I want you to be able to say, hey, we did a measurement here. We know that there's a good reason to put inline on this function. And personally, I'd want to comment on it. Otherwise, I would just delete it. Be like, why is there inline here? Delete. That's how I roll when I'm doing code reviews. No, I'm exaggerating. All right. So the comments here, you all have the link. Inlining is a code smell. It's almost always better to let the compiler do its calculations here. We did answer the question of what does inlining mean. Is there any other questions? Ben comments that removing a bunch of force inlines from an old code base actually sped the program up. Let the compiler decide, right? Okay, so the next things that I have up here are Constexpr and Constituel. And again, I'm doing much of these demonstrations with free functions because the meaning is exactly the same. So a Constexpr function, I'll let Ben describe what a Constexpr function. Just kidding. Although he can if he wants to. All right, Constexpr function is a function that may be called at compile time. So I have this Constexpr auto I, and I'm calling this Constexpr function. And this is saying to the compiler, I would like you to calculate the value of I at compile time, Constexpr variable versus Constexpr function. So the Constexpr variable is one that should be known at compile time, and the Constexpr function is one that is allowed to be called at compile time. Now, if I try to assign this line right here, auto j, to a Constexpr variable, to a non-Constexpr function, from a non-Constexpr function, then I get a compile time error because I'm trying to calculate j at compile time, but I don't have a Constexpr function that I'm calling it on. And if I remove that, then this is going to compile again. I think a lot of people overcomplicate Constexpr in some ways, but that's fundamentally what it comes down to, is asking for something to be calculated at compile time, data to be available at compile time. And notice I've used our maybe unused attributes here so that we don't get warnings, because I didn't want a bunch of warnings over on this side. So yeah, that's what Constexpr does, allows it to be called at compile time. Constituel, slightly trickier. And I'll look and see there's questions here from Chris. Tim, what about if the inline function def is outside the class definition? You actually can do that, right? I think you can.
But I mean, without the inline keyword.
Wait, sorry, what's that?
Without
You're
the
gonna-
sorry, without the inline keyword, like you were saying, you would just avoid specifying inline, but you're essentially marking functions as inline if you're going to define them outside of the class definition, right? Like
If you define them inside the class, then they're implicitly inline, but the compiler is still going to do a different calculation if you actually add the inline keyword here. And you're saying, though, if I declare it and then define it, is this, I'll make sure I'm getting your meaning here.
yeah, I'm assuming you need inline there
You don't,
by actually doing that putting that in a header file.
oh, if you wanted to, yes, you have to do something if you put that in a header file, because then you might get a multiple definition if it's not inside the class body, right?
Yes.
I don't ever do that. Like, I've seen like one code base that does that. I'm like, you know what? If it's in the header file, I'm just putting it in the struct body, right? That's kind of just how I roll, but that's a good point. So you might need inline there. But that, again, comes down to using inline for linkage concerns, not for compiler optimization concerns. It is a subtle difference. And yeah. So I guess this is where I would say, this is definitely a code smell and should require a comment. And arguably, in my opinion, if you did this, I would kind of want to see a comment too. You'd be like, or something, you know, like some comment is to specify why. Maybe I'm overthinking it in this case. I could be convinced either way.
I agree. Like, and also I would expect to see like you actually using some compiler specific magic to force inline because you measured it and there's a reason, and I would describe that in a comment rather than seeing code that looks like this.
Well, it's
Right.
trading off a stylistic, like you said, you just prefer to write your inline functions in the class definition, whereas that, like, I don't prefer to do that. I prefer, even though it's a little more replication,
And
I might not like to have a giant class declaration or or definition that
That I would buy, but you wouldn't want the inline in the declaration up above because that obviously.
Oh yeah, that's fine. Okay.
But you, for what you're describing for this case where it's all in one header file, you do have to put inline here, right?
Yes. Like you
I-
said, for linkage.
For linkage. Yeah. Okay.
I would assume you have to put it on the definition, not the declaration.
I put
Yes.
oh, definition, not
I think so.
declaration. Like I said, I so don't do this. So there, like that. Okay. Yeah. All right. Yeah. I won't argue with that. Won't IPO inline across compilation units? Yes. If you can do whole program optimization, interprocedural optimization, whatever your compiler happens to call it, it can inline across compilation units as well. I heard a rumor that outlining cold code blocks can give performance improvement. Yes, that definitely. That's kind of like how if you do profile guided optimization, Visual Studio is particularly aggressive about this. If you don't call a function during your PGO run, then Visual Studio will take that function and like put it in the dumpster out back. And then when you need to call it, it's extremely expensive. To the point that if you don't exercise those functions during your PGO run, and then you have another run that does use them, you'll probably see a pretty significant performance hit in that case. That's Microsoft. Is the term inline applicable to templates at all? It is, right? You can do inline templates, I think, pretty sure. No, extern templates you can do? I don't recall now. But do you mean template functions or do you mean template classes is the question for Dima.
Both.
Ben answered it. Okay. Template number functions. And, no, we got scrolled past. What happened? All right. IILE from Jacob immediately invoked Lambda expression, I believe, is what you're referring to there. No? No? What do you mean with IILE there, Roy?
Yeah, Roy replied to me directly and
Oh, okay.
said that that was the case.
Okay. All right, you all have your conversation. I'll get back to this talk.
One last comment. Stylistically, I like to put the definition of the inline in the class definition when actually the meaning and the definition of that function is really just the inline code itself. Like it's not going to vary at all implementation wise, but it's like kind of like a not equals operator being the complement of a equals operator.
Mm-hmm. So that you're saying, if I'm reading you right, from a readability perspective, as someone's going through your code, you're like, well, obviously the not equals. Okay, I see now the not equals is defined in terms of equals or
Yeah.
whatever.
Yeah.
All right. Yeah, I could see that. I also just, if we wanted to keep discussing this, try to prefer classes that are small enough and functions that are small enough that if it's all right there in the body anyhow, then it's less of a deal. But yeah, I'll definitely give your method a consideration next time I'm working on a new class. Think about that. All right, so we had covered Constexpr. Consteval requires a function to be called at compile time. That's not maybe, that is correct. But the problem is that it requires a function to be called with values that are known at compile time. So if I've got this consteval function here, and I want to initialize a constexpr I from calling this function, I can. I'm passing in this value 3. 3 is a value that is known as a compile time. It's a compile time constant. This function compiles, no big deal. And then I call it again, but in this case, I'm not assigning it to a constexpr value, and it's fine, but I am passing a value that is known at compile time. This I is a value that was known at compile time. But if I uncomment this and I try to call consteval function with J, which note J is not a constexpr value, then it is going to fail to compile because J is not a value that's known at compile time. So there's no way for the compiler to evaluate this at compile time. There's then an argument to be made. And so if anyone's curious, inside the body of this function, even though val must be known at compile time for this function to be executed, I cannot treat val as a compile time constant. I cannot use it in context where a constant expression is required or where a compile time constant is required. It's still inside the body of this function. It's just a variable like any other. But when I call it, I'm required to call it with a value that's known at compile time. It's a fine line for some of these things that take knowing more about the compiler than you should have to know for why that compiles, but would be too much of a tangent. So we'll take that out.
So does that mean you can't call, you can call another const eval function with val though, right? Like from inside of const eval func. Can't you just call another const eval func with the val?
Yes, you can.
So in that case, you can't static assert with val, but you could static assert with like an identity that just passes val back to you in const eval form or something. I don't understand why you can't use val as a Constexpr or as a compile time constant.
Yeah, I don't know.
Okay.
I don't have a good strong answer for why not. I saw it come up recently, I don't know, like last month on Twitter or something. I'm like, oh, yeah, that's a good point. They should have made it so it was a constant expression while the function's being evaluated. Huh. It does almost feel like a loophole though, doesn't it? That you can call another const eval function and pass it a value. Oh, but val had to be known at compile time, but you can't treat it like a compile time constant. That does seem silly, doesn't it? It really does seem like you should be allowed to do that, but no, non-constant condition for static assertion.
And so you could just you could have a const eval function that just passes through val. It just takes val and then gives you back val, and you could static assert on that. This is so esoteric.
It is and it isn't. And I believe I can give you a reasonable answer why here. So you're saying create an identity function, and then you're saying, well, I should just be able to. Can anyone tell me ahead of time why this isn't going to work?
Val is not you can't have Constexpr parameters.
Val is not a constant expression. Yeah, it's still not a constant. It's still not a Constexpr parameter. But also, you cannot put. Hold on a second. Oh, okay, never mind. I had something wrong there. All right, don't worry about it. So no, you still can't do it, Jacob. Don't try.
Okay, this left me more confused, but we don't have to talk about it now. Because we're calling other func just fine, but whatever.
We're calling other func just fine, yes. And I agree that actually does seem confusing. I will have to totally agree with you. Yes. Does anyone else want to be confused about something? So it reminds me of how is constant evaluation is always true if in an if Constexpr context. Yeah, you don't want to use if Constexpr with is constant evaluated because it, yeah. Yeah, there's all kinds of discussion in the chat window to go back to. Okay, virtual. Now we're getting to the relatively mundane. I saw right now there is a Humble bundle up that has some programming training material up there. And some of it is like C++ training material of some sort. And the description says, teaches you modern programming techniques like object-oriented programming. Like modern, like object-oriented programming, huh? All right. Okay, we'll continue on. But virtual is good old-fashioned object-oriented programming in C++, because object-oriented programming is from what, the 60s? Does that sound about right? Yeah, we're postmodern now. Yeah, there you go. Ben found it. Are you going to buy it, Ben, and see what they teach you? Okay.
I think I already have the C++ crash course on my bookshelf.
Oh no, that's the book one. The one that I'm referring to is actually videos on Humble Bundle right now.
Oh, okay.
Yeah, I think that's right. Because it's some bundle that's geared towards people who want to learn game programming or something. Okay, so virtual is used to declare a function as being overridable by a derived class. If you don't use virtual, you're actually hiding a function. And this is a topic that I can like literally spend a half day of training material talking about hiding versus overriding versus overloading and virtual and override and final and all these things. So I tried to keep this at a pretty high level here, but I've got this function called virtBase, or excuse me, class called virtBase, and I am inheriting from it, deriving here virt derived, and I've got this function, get value is not declared virtual, but this one, and this one is also not declared virtual. So I just create this little demo here. I have a function called get value that takes a virtBase base by reference and returns what its value is. I need to pass it through as a reference or a pointer to the base class to illustrate the point here. And if you call this get value, it creates a derived object, and then it calls this get value with the derived object. So right now, what value do I expect this function declared on 189 to return? Anyone?
2.
1? Well, I'm getting ones in the chat window here. It is 1, and I can reveal linked code. Reveal linked code. Hey, I didn't actually reveal the linked code. All right, get value. So get value is in fact returning 1. I can see that here in the disassembly output here. And that is because I did not actually declare this function virtual. So since I was accessing it via a reference to the base class, I was getting the base class's function. If I make it virtual and I access it via a reference to the base class, then I'm going to get the most derived version here, which is going to be returning 2 here. So I am returning 2. So that's an 3, 6. Okay, you all are.
5 is right out.
Yeah, 5 is right out. Okay, so that's the high level idea of what virtual means. It allows you to change the behavior in your derived class. So I get the impression most of you had some idea what that was about. So I will move on. But we should add a no override or hide attribute for such cases. Yeah, all right, could be interesting. So final and override are there. One of them protects us from ourselves. So if I've got this function marked override here, this all compiles, then I'm saying I want to override this base class here. And for override to work, there must be a function in a base class that is virtual, that has the same function signature that we do. So if I comment this out and I try to uncomment this one with an int here for the parameter, it's simply not going to compile because it doesn't match the function signature of one in the base class. And yeah, nothing else to say there. Oh, no, wait, actually, there's something else to say there. If I take off the override, then this actually becomes hiding the function in the base class. This is not almost certainly not something that we want to be doing here. So override protects us from ourselves, and compilers are getting really, really good about telling us when we should have put override. Now, if I mark a function final, then this is saying no further class can override this function. So if I mark this final, then I get a compile time error in our further derived one here, because it's trying to override a function that was marked as final. Yes, lacking override is still virtual if it's virtual in the base class. And final implies virtual. Override requires the base class to be virtual. But you never want to use all of them together. So in our examples up at the top, I had a virtual final override. Don't do that. There's definitely a best practices here of use at most exactly one of override, final, or virtual, because you actually can create weird cases. Let's see if I can do it. Well, cases like that. There's other examples that I just can't recall at the moment, where you can like declare a function that's virtual and final, even though it's not actually overriding something from the base class. But so final can only apply to virtual functions. There we go. That's so virtual doesn't imply, final doesn't imply virtual. So there. And then pure virtual. No, final does not imply override. They are definitely different. You don't want to use final and override at the same time, like I showed. Then we can do. I can't recall the example. I had a good example for why doing final and override at the same time is a really bad idea. It might actually be in my book, and I can't recall it right now. All right, we're gonna have to pull this up. If I do that, can you see my new window that I just pulled up, or do you see the old one only? Do you see an empty edge window, right?
Yep, we see it.
All right. When used in a virtual function, declaration or definition final ensures that the function is virtual. That doesn't even make sense. When used in a virtual function, it ensures that it's virtual. That's not helpful information. All right. What did the compiler actually tell us here? Since we are now going down this road more. The compiler says marked final, but it is not virtual. So no, final does not it does not imply virtual, but override, I think, does imply virtual, but it's meaningless because it can only be applied to a virtual function anyhow. Yes, core guidelines, exactly one of these things. You can have the link from Ben. Okay, so pure virtual functions are functions that are virtual and we declare it equal to 0. And I saw some, Chris says that he wrote override. Final on a non-virtual is an error, so it must imply override. Okay. I'm gonna, once we're done, I'm gonna go back and find the example that I was thinking of, and we will talk about that, if that's cool, Chris. Thank you. So if a function is equal 0, then it is a pure virtual function. It creates an abstract base class, and that requires you in a derived class at some point that you must implement your pure virtual functions, because you cannot instantiate a type that has any pure virtual functions. It is an abstract type. So if I try to comment out this abstract base here, then I get an error. Cannot declare a variable AB to be of abstract type abstract base because it has undefined functions in it. And if we have this follow-up example here of abstract base 2, it is actually valid to make a function that is pure virtual and provide an implementation for it in your base class. So you can be in a situation where you have something that has an implementation, but you're not allowed to instantiate that object. We're still not allowed to instantiate one here because it has a pure virtual function, but we did provide an implementation for it. Now, this has an interesting use case, depending on what your exact goals are, to actually provide a default implementation. So you're telling the user of your class, the consumer of your class here, that if you're going to inherit from me, you must provide your own implementation. However, I have been nice enough to give you a default implementation you can fall back on. And this all works. We can do this. There's I think that was a note from Ben saying that adding virtual uncovered a bug that was 4 years old in a code base that he worked on. There's anecdotes also from Victor Chura that he's given at various conferences talking about applying Clang tidy across old code bases, where he said applying override automatically with the Clang modernized checks found so many bugs in their inheritance hierarchy they didn't know how the code worked in the first place, which is easy to believe in an old code base, for real. All right, where are we now? We're at 7:10. Okay, but where are we in this talk? I don't even know. Here are our original examples. I copied them in here, but I gave them new names. This is base 2 and derived 2, so this can compile. And then I'm just going to remove the things, and this is what we have left. We still have to talk about these, no except, default, delete, and explicit, and no discard on constructors. I actually set aside no discard on constructors as a different topic. So any function can be equals deleted. And it just makes it illegal to even try to call that function. This, to me, is an awesome tool. So I say, you know what, this function really should only ever be called with integers, but I find that the other people on my team keep passing in doubles and implicitly truncating them. And, you know, like it's driving me nuts. And, you know, I would say, well, just put on W conversion here. But a lot of code bases were not developed with the discipline of W conversion, so they cannot turn it on because it would be too painful for them. So you can just go in and delete this. And if I try to call it, then I get use of a deleted function. Now note, I made this one a float, even though I passed in a double, because this literal 3.2 is a double. The compiler is still going to say use of deleted function because that's the best match instead of converting to an integer, but it can do the same thing here with a double. So I love the ability to delete functions when they can become problematic, something that I think everyone should keep in their toolbox. Equals default applies to special member functions. Default constructors, copy and move constructor, copy and move assignment, comparison operators as of C++20. These things can be explicitly equals defaulted. I don't know if I'm missing something else that can be explicitly defaulted. If I am, let me know. Oh, destructors, but that's also a special member function. So this is actually the best place, in my opinion, or one of the most helpful places, that and default constructor, to say, I've got some inheritance hierarchy here. I've got virtual functions. Which equals default functions are no except now, asked Ben. It should be that if you explicitly equals default it, it will implicitly be no except if that's what the compiler would have done in the first place. By not adding no except, you're not saying that it is an except function. It will add no except if it can for the special member. I'm pretty sure that's right. It's true for Constexpr on the special members also. Yes. But virtual equals default's never going to add. So if we need a virtual destructor for our inheritance hierarchy, then we can explicitly default it. And notice I have a bunch of words here, so you can look at them later. Can the default virtual destructor have override? That's an interesting question. There's no reason. Well, there's very little reason to ever explicitly default an override destructor because the compiler is going to do that for you anyhow. If I make a virtual destructor here, then all of my base classes will inherit a virtual destructor from this one. All of their destructors will be virtual automatically. But you should be able to do that. You should be able to do, well, and you wouldn't make it virtual, right? Because use exactly one of virtual override or final. You could do tilde, whatever, my class override equals default. That should work. And then for completeness here, for following the rule of 5 here, I just went ahead and I deleted the rest of my special member functions because we don't have the answers at the moment for how exactly those could be implemented here. Yeah, so Dima's asking why a destructor would be overridden. They all have different names. You're saying I want to override the base class's destructor. So even though they have different names, you're still talking about the same function call chain. But it's really weird, right? Virtual for destructors is like flipped inside out and backward from how virtual for regular functions work. Virtual for a regular member function, when you call it, it's going to call exactly one version of that function. It's going to call the most derived one, the one that's correct for the object that was passed in. Virtual for the destructor, when you call the destructor on the base class, it means that it will call the derived class's destructor and then call the base class's destructor and make sure that they all get called. So it's different for sure. And then this is, again, something that could be like an entire day's discussion. But if there's any other question or comment, then all right, I'll keep talking. No except says that a function is not allowed to throw an exception. It can take an optional constant expression. Now here I've just hard-coded this in, true and false, but this can be like a type trait. You can be like, this function is no except if, I plus j is no except or whatever. This code is perfectly valid. I can say throw 4 inside of a no except function. The compiler is going to warn that this is always going to call terminate. No except doesn't mean that it won't throw an exception. It means it's not allowed to throw an exception. If you do throw an exception from a no except function, then it is required to terminate. And yes, Jacob, no except, that is a code smell, but it would be something like, so I am saying if the expression 4 plus 5 is no except, then that's going to give me a constant expression. That this is a constant expression. It's going to give me a compile time constant back. Then I want to declare this function as no except. It's definitely smelly. That's definitely worth a comment on it as well. Again, no except is like, and I've done that talk before. That's an hour talk all by itself. All right, moving a little bit faster. Why is it a smell? Oh, what is, yes, all right. So why is it a smell and what is the alternative? Fine, you're gonna make me deal with it then, are you? It's a smell in the same way that requires is a smell. The requires means, well, I probably should have specified a concept. And no except means I probably should have specified a type trait of some sort. So I could have a my brain is failing me at the moment. Oh, I have an idea. So say I've declared some struct, and I want to say no except that this function is no except if the default constructor for my type is no except. That's what I'm doing here. A much better thing to do would be with, I think is actually, I managed to choose for my off-the-cuff example, the longest named type trait in the standard. No throw default constructible, but I haven't included type traits yet. There we go. Is no throw default constructible. That actually declares the intent. So if you have no except, it means that there's probably a better type trait available, or you could write one for yourself that declares the intent of the code here. Is that an acceptable answer, Chris? Ben, let's discuss this in beer time. Okay, that's like a philosophical argument here. If I pass a function pointer to another function and it calls it, function pointer to another function and it calls it, I don't know if that's in the context of no except function specifically or not, Chris. Yeah, okay, yeah. So I would still say, you know, code smells, I sometimes have to clarify this on Twitter. Code smell doesn't not mean this should never ever happen, right? It means it should make you raise your eyebrows when you see it and wonder why that was done instead of maybe something that's a little bit more explicit or more readable. I never, if I say the words code smell, I never mean this should never be done. I just mean something that you should, you know, maybe reconsider. Okay, all right, what's left? We have this was our last example, and I removed the things that we've already covered. And now I've got no discard constructor and explicit. And we still have our const volatile and reference qualifiers. No discard for constructors. We already covered no discard for regular functions. For constructor, it means that you don't want to ever discard an object of that type. Not in the same way, not if it's returned from a function, but I'm saying if I do this, if I try to create this object here on the stack, I'm not calling a function, I'm just trying to construct the object. I now get a warning because this constructor is not marked no discard. Now you're probably looking at my comment right now that says, look at the GCC bug that I just found, because I was trying to create an example for this. And it turns out that if you try to put no discard on an explicitly defaulted default constructor, GCC doesn't warn when you discard it. So that's definitely a bug in GCC, I would say. Someone might know better than I would here, but I'm pretty sure that would be a bug. So what types, why would we ever want to make a function, a type like this, no discard? Did you actually mean operator comma, Ben?
Yes.
You actually, we're not going to discuss operator comma and its interaction with no discard. Do you mean the overloaded operator comma or just in general operator comma?
In general,
Okay, fine.
we can discuss that later.
Actually,
this
it
isn't-
is.
Oh, yeah. Okay.
Okay, so it seems that it is not giving me a warning on the fact that I have discarded the right-hand side of the comma.
Yeah, and if comma was overloaded, how would it know you were not using it, right? Because it's calling operator comma with no discard.
Right. And the takeaway is never rely on operator comma. Okay, all right, fine. I'll give one last effort here. Cannot convert no discard to int. Wait, I'm not trying to.
Ends there because
Oh, because of operator precedence.
because that comma isn't operator comma in a declaration otherwise.
Yeah. Ignoring return value of no discard. Oh, okay. So it actually did do the right thing here. Well, pass an unnamed object to a function. Yeah, you can still do that. If you were to just pass this directly to a function, then you haven't used it in no discard context. It was given a name, even if it was a temporary name, it was still given a name. Should not warn there. Okay, so why was no discard added for constructors? That's what I want to ask the question right now. What's a good use case? Okay, Nathan, lock guard. Yeah, locks, mutexes, or not mutexes, but locks. Anything that's like a sentinel type object that you might have a reason for it to make sure that it was used properly. Now, this is where things are going to get very interesting. Explicit disables implicit conversions, right? If I don't have explicit here, then I can use a 5 as if it were an object of this type explicit. The no discard equals default constructor seems to work correctly on Clang, wrong on GCC and MPC. All right, thank you, Jacob. Okay, I want you all to look at this code with me, because this code very much surprised me to the point that I had to take a break from preparing this talk. And to me, this is one of the more interesting things here. I have marked the integer single parameter constructor explicit. I have not marked the double single parameter constructor explicit. Now, if I call this function use explicit that takes a const explicit reference, we're used to code that does implicit conversions all the time, right? We pass in character string literals to functions expecting a standard string, and the compiler does this conversion for us. We all do it all over the place. So that's these functions that are not marked explicit. What happens if I uncomment this line of code, use explicit, and I pass an integer into it? Is it going to compile? If it compiles, what does it do?
I hope it doesn't compile.
You hope it doesn't compile. Jacob says, I think it implicitly casts to double, and then calls the explicit double constructor, I'm guessing. Okay. Some votes for double. This one. There are times when I wonder about this. Yeah. You hate that your gut reaction is that it's going to do the unexpected thing. All right. So I'm going to uncomment it. And so I'm calling this here. Let's do this. Use explicit. And it gets a pointer to LC0. LC0 is double. I can read the disassembly here and see that it does, in fact, call the function that takes a double. And that is just incredibly obnoxious. I'm going to try turning on W conversion to see if we can get a warning. And we're not even getting a warning out of it. I read that right? It's yeah, the compiler didn't even put the int constructor in the output at all. Like, it's like that constructor is never called. You're clearly only calling the double one. So yeah, we removed this explicit conversion from our possible options. So I guess it defaulted to calling this one and did an implicit integer to double conversion so that it could do an implicit double to explicit conversion. Isn't that great? Yeah. Oh, what if I delete explicit? That one? Well, I can't delete it like that and provide a body, right? Yeah, that's definitely going to compile because it's going the double route. Then if I delete that one, then it gets use of deleted function. I guess that's a thing. So the general best practice here, by the way, is that all single parameter constructors should be marked explicit, and then you're not going to get an implicit conversion like this. I need a drink after seeing this. Awesome. Thanks, Charles. That's I know I did my job.
What happens if you provide a template constructor that is deleted? The primary template is deleted.
Hold on a second. Temperature is dropping rapidly in here as the sun is going down outside. A new keyboard, getting used to it. That should fail to compile because yeah, it's going to use the this is not a good match, so it's going to go to the template. Who all saw that awesome article that was the Street Fighter 2 characters fighting it out over however function resolution works? Yeah, see, awesome stuff. All right, so yeah, that really surprised me. I'm like, I'm just gonna create the simple example for the meetup, and I was like mind blown. I had to take a break. Like, why is this happening to me? Well, you're saying if we don't use, yeah, if we don't use explicit, then it would do what we expect because there's, I needed to try to imply an implicit conversion here. So if I do that, then it should call the integer version. Yeah, we see now that int actually shows back up in the compile output, and we can see that it prints double and then it prints int. Yeah, all right, you know what? That's all good and well. So in C++ 20, explicit learns a new trick. Explicit, we can be conditionally explicit in C++20. So you might do something like allow implicit conversions if the type that you have contained is trivial, for example. It's just an idea. If this doesn't mean anything to you, don't worry about it. All single arg constructors are explicit or none of them are. Yeah, that sounds like a great idea, but I would still lean towards all are explicit. But yes, definitely don't mix and match them. You're not going to get the behavior that you thought you were going to get. Either that or you're really going for something very crazy. All right. So now all that's left is const, volatile, and our reference qualifiers. So I just have a few little examples here of const and volatile in all of the ways that they can be combined. Now, keep in mind that many uses of volatile, no, explicit is not just used for single arg constructors either. It can also be used on default constructor if you really want to be fancy about that. It can be 0 to many, and it comes up with braced initialization when passing to a function or returning from a function. Yes. Yeah, okay. So I am attempting to wrap this up before it gets terribly late, but on multi-arg explicit functions, nobody talks about it. Okay. But all right, no, see, you all are just distracting me now. So if I've got this function or this class called const volatile, I can override get value 4 different ways just based on constant volatile. If it's a const object that I'm calling this function on, then I'll get the const version. If it's a non-const, I'll get the non-const. If it's a volatile non-const, then I get 3. If it's const and volatile, then I get 4. So I can actually demonstrate this here by creating a regular object, one that's const, one that's volatile, and one that's const volatile. Don't actually do this. Don't make overloads for volatile with your member functions. It's highly unlikely that it's going to do anything reasonable. None of the standard library classes have volatile overloads for them. Pair doesn't have it. Well, no, that doesn't make sense for pair, but tuple doesn't have accesses that are volatile. But I can do C1, C2, CV3, CV4, get values, add them all together, and we should return 10 because I'm calling 1 plus 2 plus 3 plus 4. And at some point, yes, I did verify that I actually get 10 here. So that's constant volatile. And then the last thing that we have here is our reference qualifiers. And I think this is probably the least, I'm just guessing, the least understood thing that we'll have talked about so far by most of the people that are here today. If it's unqualified, then it can be called on an object regardless of what the context is. If it's qualified, you have L value reference qualified and R value reference qualified. So that's what this ampersand is here. And when I had it like const ampersand volatile or whatever in my examples, I'm not saying a logical and, I'm saying that this is a function that can only be called in an R value reference. And for the sake of this argument and for the sake of this discussion right now, let's just say that those are temporaries. So this, and note that I cannot mix these. I cannot do this one because this is going to, well, it actually explicitly says you cannot mix qualified and unqualified member functions. So we'll comment that out. Now this function, get a reference qualifiers object. I'm just getting one of these things. I'm returning it. So it is definitely a temporary. It's coming back from a function. So it's definitely a temporary. It's an unnamed object. Well, it will be temporary, sorry. Right here, I'm assigning it to a value. If I call this, then I'm going to return 1 from the function. I lost my location. Example reference qualifiers. There we go. All right. So I'm returning 1 from the function here because I've called this on an L value reference. So this is a named object, and I got ahead of myself a moment ago. If I comment this out and uncomment this one, then I am calling it on a temporary. It's an object returned from a function. It's temporary. It's definitely an R value. And if I call this, then I'm going to get 2 returned from the function, which I can see this is the line of code that just changed here because I'm calling it on a, on an R value. And that in itself is like an entire day-long discussion about L values and R value references and stuff. But we can actually see that standard optionals value member, if you want to go back and look at that, actually has L value and R value qualified things, because if you want to call dot value on an optional that was returned from a function, for example, on a temporary, then it makes sense to get an R value reference back out, and it overloads on that. Should copy assignment operators be L value reference qualified? Yeah, a lot of people would argue for that, Ben. I haven't spent enough time with it to have a strong opinion, but I do know that other people that do think that they should be L value reference qualified. So that's say you can't do weird things like, actually I can demonstrate that. Like, that's weird. Line 517 here, that's weird because the default assignment operator is not reference qualified as an L value reference. So even though I'm like returning, I'm assigning to a temporary that's returned from a function, that's weird. And there was another comment. Can the constructor and destructor be volatile qualified? Does not make sense for the constructor because the object doesn't exist yet. So I guess if the object was declared volatile and you're calling the constructor, I honestly have no idea if that can be volatile qualified. The destructor, I would say definitely not before C++ 20, because you could not overload, sorry, you could not overload destructors before C++ 20. But with C++ 20, you can do things like have concepts on destructors to choose the most specific destructor. So I don't know. That's an interesting question. Well, let's try the volatile real quick. And then I will be officially wrapping up this talk. Destructors may not be CV qualified. I could see an argument for making a constructor volatile qualified, but whatever. All right. That's the end of my rambling talk here, where I tried to cover all of the possible ways that you can decorate member functions. As we can see, I missed a few details in a few places. Yeah, thanks for everyone for hanging out. Does anyone have any questions that make sense before we get to happy hour? No one has any questions? All right.
Apparently everybody's thirsty for happy hour.
Yeah, or I answered enough of them or brushed them off enough, telling Ben, no, we're not talking about that right now.